in order to input into these formulas that we talked about yesterday. Okay, so some of the stuff that's in these formulas, we need a sample mean from every sample. Okay, we're going to need the sample standard deviation, or in this case the variance, from every sample. We're going to need what we call the grand mean. So we're going to take some time in Excel and come up with those things real quick. Okay, so just so that I know what the values are, I'm going to label this row as means, and then under here, find the mean of that first array of data, which was A1 to A10. And then close that off, hit enter. It gives you 20.1. Okay. Now you can do the exact same thing for that cell and that cell, but we've copied formulas before. You can copy formulas, and we've done it basically copying in columns. You can copy over to the row as well. And now you can see that as I double click on that one, it'll show you I'm taking the average of that blue column, average of that blue column. So we got the mean of each column, right? Okay. We need the variance. Okay, so I'm going to take the variance across, and then it equals VAR dot S because of the sample. We'll go from A1 to A10 again. So that's going to be how we determine the variance. And if we do not use Excel to do these things, the problem is probably 3 to 4 times longer than what it normally is. Because finding the variance by hand, you got to take the mean, subtract it away from each data point, and all that kind of stuff, square it, add all that stuff together. That's a pain in the butt. Hit enter, and then I'm just going to copy that straight across. So now we've got the variance for every one of these pieces of data. Say again? Nothing? All right. If we need, so the next thing we need is what's called the grand mean. Okay? And the grand mean, ultimately the way we think about it is it's the mean of the means. Okay? I'm going to take, there's 2 different ways we can do this. We can go equals and then average of those 3 things there. You know, average your 3 means. Okay. Close that off, should give you 19.46 repeating. Okay. A little bit of algebra will tell you that if we're going to take the average of these 3 things, but each one of those was the average of these, then the grand mean can also be found by taking the average of all 30 data points. Okay? So it's the average of all your samples viewed kind of as a single group. So it'd be taking all those, add them up, divide by 30, and you see that gives me the same result. So there's 2 different ways that you can process the data to find the grand mean. They're really the same way, okay? But if we're doing it by hand, I think the grand mean, finding the average of those 3 would probably be quicker. So right now, those are the things that we're going to need to process this stuff. Okay, so I want to work through trying to find the other pieces of information. Okay, now, yesterday we talked about the scenario. These are the ages of females getting married in these 3 states. Our null hypothesis, okay, regardless of how many populations you're trying to study, you're going to have mu1 equal to mu2 equal to mu3 equal to mu4 equal to mu5, however many populations you're trying to relate to one another. This then is always going to be your alternative, that at least one of the means is different. Okay. The only hang-up between this test and our results is that the results do not tell you which population is then different if there is a difference that can be realized. It just says that they're not all the same. Step 0 here, I don't want to talk about that yet because we haven't really looked at the F distribution. what happens is that the F distribution is it's a skewed to the right distribution that starts at 0. It's the way that we're going to always decide with our hypothesis here, our null hypothesis, is it's always going to be a right-tailed test with the F distribution. So once we get all our data values and we call our F statistic, I'll spend some time talking about step 0 here and how we'll actually make our decision. Okay. So step 1 is to do what we just did in Excel. So it's giving us those values there of 20.1, 18. I just copy those over from the Excel page. Okay. We've got our variances from each, and we found our grand mean. Okay. Now finding the mean square between. Okay. The mean square between, and what this is doing is allowing us to look at this here compared to that. So we're looking at how this sample varies compared to that one, compared to that one. Okay. When we say varies within, we'd be looking at how 18 varies to 19, varies with 20, varies with 21 in that sample. Okay. So mean squares between is this formula here. Okay. In this formula, we've got the need for K. Okay. K is the degrees. K is used in the degrees of freedom. Okay. And K is your number of samples. Okay. So we had 3 samples that we were looking at. When we say that we have the sum of n sub I, n is your sample size, I, in this case, and maybe it makes sense to actually put down here on the summation that I is going to start with 1, and it's going to go up to K, which K was 3 for us. Okay? So basically we're saying, okay, well, if I is 1, then we're talking about the first sample. Okay, so how big was the first sample? We go through here because n is the sample size, right? So it's asking how big was the first sample. We've got 10 objects there. So we'll have n sub I is 10. Okay, now x bar sub I. Well, if I is 1, we're asking what was x bar sub 1? And that would have been the 20.1, which I identified as the New York row there. So 20.1. We'll go here. And then we're going to subtract from that x double bar, which is the grand mean. So 19.47. We'll square that. Okay. Now, because this is a summation, that's what we get for I being 1. Now we've got to go to I being 2. So if I is 2, we're looking at the sample size for sample 2, which again was 10. And then x bar sub 2, which is the sample mean of sample 2, which I guess I didn't edit these. That should be a 2 and that should be a 3 there, is 18.2. 18.2. So 18.2 minus 19.47. We'll square that. And then we're going to add to that n sub I when I is 3. So this is sample 3. Its size, again, was 10. And then x bar sub 3. So the sample mean from sample 3. And it was also 20.1. Okay. Minus then 19.47. I think it's important, and it's because the problem here just set up this way. A lot of people, because of the way this first problem is structured, think that is, if maybe we do another problem, they think that number should always be the same number. It doesn't. That's the sample size for sample 1, sample size of sample 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, of sample 3. And they can be different. Here they're just, because of the way the problem was written, they're the same. Okay. Then we're going to divide that by k minus 1. K was 3 minus 1 gives me 2. So that is our MS sub B. Okay? Now we have to do MS sub W. Okay? MS sub W is this formula here. Okay? We're going to take the sum of n sub I minus 1, s squared sub I, so that's your variance that we established earlier in Excel, and then we'll divide that by n minus k. Okay, so the sum I, and what was in the parentheses? Trouble remembering it. N sub I minus 1. N sub I minus 1. Okay, so here we're looking at n sub I minus 1. So n sub I, again, that's the sample size of sample 1. Sample size of sample 1 was 10 minus 1 times the variance of sample 1. So the variance of sample 1 was 2.77. 2.77. Then we're going to add to that n sub 2, so sample size of sample 2 minus 1 times the variance of sample 2, which was 5.73. And now we're going to add to that n sub 3, so sample size of sample 3 minus 1 times the variance of sample 3, which was 4.1. And now we're going to divide that by n minus k. So capital N is the total number of objects collectively in all samples. So capital N is equal to N1 plus N2 plus N3 in this case. Does that make sense? Which would have been 10 plus 10 plus 10, so 30. So 30 minus K, K was 3, so this is going to be 27 there. Is that okay with everybody? All right. Yes. Well, because this is, so S is the standard deviation. And so S squared is the variance. So, and that's always something to think about, because you can use, I could have used a standard deviation and then squared it, but if I use just variance, because that is standard deviation squared, it's just, you just got to make sure that you know which one you're using. Huh? Okay. So, we'll then, and we're going to run out of time here, so we'll compute that. Okay, so we'll do this one up here in red, and we'll do this one down here in blue. And we'll take those two values and we'll divide them and create this F statistic. Okay? No. Then that F statistic is then going to be compared to an F critical value that's based off of our alpha of 10% that we started with. And if it falls to the right of that F critical value, we will reject our null hypothesis. If it falls to the left of it, we will fail to reject. So that's what we're going to do on Monday. We'll finish that up. And then I will show you how much easier it is to use Excel. And then my hope is that you continue to use Excel after that. Huh? What's the answer to these? I don't know yet. Actually, maybe I have it written down somewhere. So that red numerator turns into like 24.0667. And the blue numerator turns into 113.4. 24.0667. And then I think if you divide those, you get 2.865.